Hi, it's repair time, or at least attempted repair time. This one comes from the EEVblog lab. This one I've had sitting around forever. The Keysight DSOX1102G. None of that black case rubbish that they've got these days. This is a good old beige box. And 100 meg, 2 gig sample per second jobby. Very nice scope, of course. But yeah, this one is, as it says on the top, rooted, as we say here in Australia. Don't know when I put that sticker on, but it was at least a couple of years ago. When I powered it on, it came up with a uncalibrated error. And if I remember correctly, yeah, I think one of the channels, I don't think it was both. Hopefully it's only one of the channels, because when you're repairing a product and you've got something like in this oscilloscope that has two identical channels, you want to hope that only one of them failed, because then you've got another channel that you can physically probe comparison to. There it is. System concerns detected. Instrument is uncalibrated. Whether or not it lost its calibration, and that's potentially another fault, or whether or not, most likely, it's related to the vertical problem. Now, I believe I first encountered this when I was using this to shoot a video, and I was measuring some stuff, and it just didn't seem right. The values seemed out. I think it just didn't make sense. So, I finally came to the conclusion that, yeah, it was rooted. So, yeah, aside it went, and I haven't had a look at this since. So let's give it a whirl, and thankfully it's got its own test generator built in. We can just hook that up to here and see. We don't need any external stuff. So let's go. Wah, 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 wah. I don't have the license code. Aw, bummer. Thankfully, we have a backup. We've got our probe calibration signal, and yeah, we're getting something. No wuckers. Let's trigger on that, shall we? Trigger type, auto, source, there's your problem. Source number 1, there you go. Like I bought one. Anyway, we could tweak that with the pot there, of course, but anyway, that seems to work. So 1 kilohertz, that's what you'd expect. I don't know what the signal level you'd expect, but let's compare it to channel 2. Now, that looks right. 500 millivolts per division, 50 millivolts per division. One of them's obviously set up for 1 to 1 there. This one will be set up for 10 to 1. There it is. So if we turn that back, no wuckers. And 50 millivolts per division. Now it's making a fool out of me. It works. Oh yeah, look. There's your ground reference. Shift it. Whoa, look at that. It's shifted down. That's right. I remember now. Yeah, it's not like the signal failed. Yeah, it's all coming back to me. Yeah, look, the DC, yeah, look at that, the DC shifted. We're in DC mode, right? We're in DC coupling. And all of a sudden, yeah, look, it's gone negative. So there's something wrong with the DC offset. So yeah, if I put both to the same level there, I can cheat here and just set it to line triggering, so we can at least see the waveform, and then we can swap between the two channels, right? Yeah, well, yeah, look, the DC offset. I didn't even notice that. Yep. So we've actually got a DC offset problem on both channels. So the sampling seems to work, the ADC's working, the triggering system's working, everything seems to be working, but we have a DC offset issue on both channels. That's annoying. So there's probably something common. That's weird, because I would have expected the DC offset to be generated when you, turn your vertical position control here. It adds a DC offset value to the signal being measured, and I thought that would have been generated within the channel itself. So, we just saw a reversal direction there. So slight drift between the 50 hertz mains and the 1 kilohertz internal. It's going to go back. It's going to drift back. Oh, lovely. Anyway, that's fascinating. I've done a video on clock drift. Actually, I might have to link it in up here if you haven't seen it. So yeah, that's a bit of a bummer. I would have liked to have had like one functional channel. So yeah, I wouldn't have expected the DC to be central, but it could just be like a power supply powering both of them or something like that. Because I remember from the teardown, there are, and as you'd expect, like some local regulators surrounding the input circuitry. So, hey, oh no, that's just pick up from here. Yeah, something just switched on. I've done a video on common mode rejection pickup as well. Anyway, let's crack it open. And just to show you what it's supposed to do, of course, here's the black version. The black version works. The beige is the problem. There you go. Fixed. All you got to do is spray paint it black. Yeah, there you go. So there's no change in the DC offset, and the calibration output is a DC reference. So yeah, something weird happening with the rooted unit where it's based on the range, like, has DC offset issues, which is interesting because I mentioned before, like, the external voltage regulator, like, you know, powering that. If that was a problem, then you'd expect it to be a problem on all ranges, possibly. So yeah, this is a weird one. Guess which unit this is? Anyone remember? Trust me, that's not factory. Those trim pots aren't factory fitted. Oh, this is my original hacker unit. I did that video hacking this scope. So, oh goodness, yeah, I've screwed the pooch. Who knows what I've done to this thing? The poor bastard. There's probably, I'm going to say right now, there's like nothing wrong with that front end. I'm going to say I've done something horribly wrong to the scope. So the first thing I'm going to have to go do is watch my video where I added these trim pots where, if memory serves me correctly, when it boots up, it reads a voltage divider and that tells it what bandwidth of the scope it is and stuff. But I don't remember that ever screwing up the... I've left some screws out here too. Look. That's a bit how you doing. Whoops. So yeah, I don't recall there ever being any issues with it. I can't remember. Anyway, this is my hack scope. Yeah, so this is not a Keysight failed instrument. This is a Dave fail. Yeah, I've done something horribly naughty to this. Okay, after that embarrassing revelation, don't hack your products, kiddies. You're going to come and gutter like Uncle Dave. Anyway, because it seems to be like a calibration issue. It says it's uncalibrated, and of course DC offset actually is part of the calibration. I think you can do an auto calibration for DC offset. So why it's actually lost this calibration, I don't know, because I remember at the time the hacked scope was working. So yeah, anyway, like maybe I dicked around. I think I vague recollection of dicking around with it more, perhaps after the, yes, I checked 2 videos that I did on this thing. So maybe we can go into utility and service and start use a cowl, shall we? Well, no, let's do hardware self-test. Let's see what pops up. Nope. There were self-test failed. Trig, comp, and mux. Oh no, that's not good. There's more to this than perhaps it wasn't my hack, although, you know, most likely it's something to do with it. But, you know, it self-test failed. It trig compensation, I presume, and mux. Yeah, what's going on? It is the 1 megazoom for ASIC, so it does mux between... no, does this mux between the channels? I can't remember. Anyway, I don't know what mux they're talking about there, but that's interesting that those self-tests failed and not DC. Anyway, let's run a starter user cowl, shall we? So we'll give that a whirl. Calibration factors are protected. Go to utilities option. Oh god, we've got a cowl protected disable. See, I would never have disabled the protection on this thing. So anyway, we're going to go disable that. Utility, options, auxiliary, cowl protect, disable that, back. Utility, service, disconnect all inputs from the front panel before using hardware cowl, or start user cowl. Okay. Oh, 7 minutes. I will get back to you. Yeah. All right. And the good thing about this is you can actually operate this with the case actually off. You can probe, as I saw in the hacked videos linked up here, because they're rather fascinating. They're 40 minutes long, so I haven't watched the whole damn thing again, because that bloody EEVblog guy likes to bloody waffle on. Jeez, you know. Anyway, you can see, look, it's shifting the DC offset there. So it's doing that for each channel. So it's going to be interesting to see what comes back at the end of this. I don't know, you know, what these waveforms are or whatever, but it's obviously generating those internally and using those. Seems like an oddball waveform to use for calibration, doesn't it? Yeah, I'm not really concerned with like doing this calibration with the back off and stuff like that. It doesn't really matter. Like, it's the front end cans are all still shielded and stuff like that. So no worries. So after all that, we got the super useful message, user cal failed. Okay, well, thanks for that. And you can see that the DC offset is way below where it should be. Unless you go to 200 millivolts, 1 volt, it's suddenly jumped back down to, oh, look, yeah, see how it goes like 1, 2, 5, gets towards there, and 10 is perfect. I guess the only thing left to do, really, is restore this thing physically to what I had before. So, like, I could go and watch my own bloody videos and work out what the voltage reference points were, and to set the trim pots and everything back to where I'm better off trying to just, physically removing the entire hack, putting back the resistors if I've still got the values. I think I'll try and just physically restore it first things first and get back to where it originally was. I might have to crack out the UART too. Yeah, it looks like I've removed all 4 of the resistors there and replaced them with the trim pot. There were 2 separate voltage dividers there and 2 trim pots. So, yeah, I don't have the original resistors, so hopefully somewhere in my video I've got the original values. Now, as it turns out, these resistors in here that I took off, going up to the trimmers up here, we actually have in the original video, here it is, the EIA codes for these, and yeah, sure enough, we've got 2 10K resistors in there as a voltage divider to give mid-rail, which is 1.25 volts, and the other one to give 0.69 volts. So yeah, we've got the exact values. They actually were marked on the top, whereas the ones on the processor board aren't. But we've got the voltages for those too. Of course, I don't have any bloody 4K7s, do I? 470 ohm, 470K. I'm bloody Murphy. Aha, we might be getting somewhere. I replaced those resistors on the main board. Haven't actually measured the voltages yet. Values are supposed to be 12.1K and 4.64K, but an E12 series instead of the E96, the 12K and the standard 4.7K, and that gives, 0.7 instead of 0.69 volts. So it's going to be good enough for Australia. And look, it's obviously detected that change, because we never had this on boot up before. System clock is defaulted, instrument is uncalibrated, the default setup was loaded. So that's promising. So maybe this could be as simple as I was simply tweaking, fiddling with. Don't twiddle with your knobs, let me tell you. I was fiddling with my trim pots. And maybe I can just completely and utterly screwed it up and put it into some mode that it didn't like, and that just, corrupted the default boot up and maybe the calibration, although it shouldn't, but, you never know. You're lucky in the big city. So, yeah, I'm going to run through the system check again, but before I do that, look at this, look at this, look at this. Ah, yeah. There's no DC offset. Let me plug the probe back in. Is that all it was? I twiddled the trim pots. Hang on. All right, there's our signal, and sure enough, that looks good. I mean, yeah, I'm sure it's probably lost its calibration values, but I don't know, maybe I don't know how we fix that, because I don't think there's any user calibration. At least the data's not available for it. But anyway, we can check exact signal levels before. But our DC offset issue is gone, and I guarantee you it's gonski on channel 2 as well. I don't even have to trigger off that to know. Yep, we fixed our DC offset issue. So that is fascinating. Just trimming the pots, and remember, we've got 2 different types of pots in there. We've got 4 pots in this thing, 2 different types. One is the product configuration, which was the ones I just changed. They're on the main board. There's 2 voltage dividers on there, 2 different voltages, which give you, here's the screenshot of the original data dump for it. Then we've got the BLT ones. BLT, of course, in Australia is a bacon, lettuce, tomato sanger. And those BLT trim pots, they changed the module configuration. So, and I haven't fixed those yet. They're still the original trim pots at whatever values I left them at. Couldn't be bothered hooking up the UART yet. But yeah, if I just put in the default resistor values from before. But anyway, it seems to have come good. But anyway, changing those product configuration bits. So with those, there's only 2 bits on the product configuration, but because we're talking about multi-level ADC reading, you can have as many levels as you want. I think there might have been 4 levels from memory per bit. So that gives you a fair number of configurations. Anyway, there are configurations where you can completely kamigata and it just doesn't do the DC offset properly. So yeah. It was those 2 trim pots on the main board that I was obviously dicking around with, but I swear I would have had this working when I put it back together and closed the case, and I swear I had used the thing. Now, possibly I could have, the only thing I can think of here is that the trim pot might have been right on the noise margin. Right? If, just being between one mode and another mode, and I thought, oh yeah, no worries, I'm in the middle. I obviously didn't hold my tongue at the correct angle, and I think it's just slowly drifted into, over time, or just like different temperature or whatever it is, the moon's not at the right phase at the moment, and it's changed product configurations, and that's just completely screwed around with it. There you go. That's a repair of my own goof. Fantastic. Okay, I'm going to start a user calibration again. Hey, look, I've got my WaveGen output back. Did that product configuration disable the WaveGen? Oh boy, hang on. Anyway, I'm going to disable Cow Protect and I'm going to go into my WaveGen. I got it. My WaveGen's back. So it looks like the product configuration can override the license in the thing. So it obviously had the license in there, but if it didn't have the product configuration, it goes, well, like physically it goes, I don't care that there's a license installed. You don't have a hardware SIGGEN installed in this thing. But do they sell this without the hardware SIGGEN? I can't actually remember. Yes, I think they might. So there you go. I think that's something that we didn't know before from that original hacking video. So we learned something new. This video wasn't completely worthless. Anyway, I'm going to go in there and start that user calibration. No wuckers. We'll come back in 7 minutes. Waveforms, yeah, the same as last time. Yeah. So they've got all sorts of cruddy things. Yeah, look, it's all over the shop. Anyway, come back in 7 minutes. I reckon it's going to work. Well, actually, I hope it doesn't. Because then we'll actually have some hardware fault to actually troubleshoot, rather than just fixing a stupid Dave goof. User cow passed. Winner, winner, chicken dinner. There you go. We can get to a point where you have got an invalid product configuration and it won't pass user calibration. You would have thought that, well, you wouldn't allow that, right? I don't know, just in case, like from a programming point of view. I don't know, programmers out there, tell me, is this like a lapse in and a bit of an oversight here, or is this, oh, well, no, of course, dick around with the hardware, you get what you get and you don't get upset. But I would have thought that like any product configuration should not be able to screw up the calibration and the DC offset and things like that. I mean, I don't even know how that happens. Surely you'd have a robust enough system so that, well, if you did get into the wrong mode for insert reason here, like you have a dickhead user who's dicking around with trying to hack the thing, then, it screws up the DC offset and looks like, for all the world, like a hardware failure. Like, I thought this was a hardware failure. And, like, my mind instantly went into hardware mode, and it technically was hardware, but not in the way that you'd expect. Like user calibration and DC offset and adjustments between vertical levels, that should have nothing to do with the product configuration. So anyway, yeah, I don't know, programmers out there, let us know what you think. Have you been involved with something like this before, where you've dotted all your I's and crossed all your T's so that no matter what the dickhead users do, they can't possibly, screw it up in this way? But yeah, trust me to do it. And it seems to be bang on calibration. I'm feeding the SigGen out, which I've set to 500 millivolts peak to peak here. And you can see I'm reading 508. So that's not too shabby at all, is it? So I can measure each range, 310, 315, that's good enough. Like, scopes are not that accurate. They're only 3 to 5% accurate or something like that. Like, a really good scope will be 2% accurate or something. So yeah, they're not that great. So let's change the range again. 310, measuring 315, no wuckers. 120, measuring 121, go back down even more. Bring it up to near full scale. When you're testing calibration like this, you want to go near full scale. 344. We're getting down into small signal levels now, so 130. So yes, I know that the calibration could have screwed up the WaveGen as well, but it's unlikely that both of them out by the same amount. So I can double check with another scope or another function gen, of course. No, I'm fairly confident that this is actually okay. Yep, 70 millivolts, no wuckers. Even down to the smallest signal levels, 9.6, we're measuring 9.8, no wuckers. And that's 1 millivolt per division, which isn't true 1 millivolt per division, because this scope is only, now we're getting into the digital stuff, but 6.7, we're measuring 6.8. Let's go up to 12 volts peak to peak. Yep, 12.1. Yeah, that's a winner. So that's kind of disappointing, actually. I'm going to have to go through and fix up the other resistors, the bacon, lettuce, tomato resistors in there, and put those back to their original values. But yeah, it looks like it was the product configuration that was screwing it up, which, I don't know, kind of makes sense. Because the other ones were just modes or something. I don't think I can't recall details of, and followed through. Some other people took the reverse engineering further that I did in those two videos and discovered all sorts of stuff. But I would change those back. But yeah, it's the product configuration that we came a gutser on here. Oh, well, what would I have done next? I would have got in there, checked any voltage regulators, of course. First rule of troubleshooting, thou shalt measure voltages. So I would have looked for any little SOT223 regulator looking package, either for the main one for the whole board, or, as I said, I believe there's some local regulation around there. Is there? Let's have a look. Yeah, I'm not sure if there would have been any voltage regulation in there or in the can. We'd have to take it off, but there doesn't seem to be any, that over there. That could be a voltage regulator, for example, but that's more got to do with the trigger system, which, by the way, the trigger system on this scope, you can actually use it as a third channel. They don't advertise it very well, but it's digital only, doesn't have the full analog front end, but you can actually display the signal. You used to be able to get this back in the old day. I had an analog scope. What was it? A COS6200, and it was a 12 channel scope, or was it 14 channels? Yes, I kid you not. It's because you could get, it was a 4-channel scope, but then you could also get the trigger view as well. This is what it was called on analog scopes, trigger view, and then you could also double those number of waveforms, because you could get the displayed sweep waveforms as well, and then it had an extra channel somewhere. I think it was at least 12 channels. Anyway, the COS6200, I believe it was. Jeez, why'd I ever sell that? That was a great scope. Anyway, yeah, I would have measured all voltages. I would have certainly checked, because when you dick around and solder and hack things like this, I would go in there and visually inspect, check for any little solder balls, because when you're soldering on a product, bit of a pro tip here, you can often get the solder can spit, give little splashes, and you may not see this at the time you're doing it, and it may leave a solder ball or a solder splash somewhere, which can then flap around in the breeze and move around in your product, or and short between pins or something like that. So you give the board a good visual inspection, then you might give the board a good clean as well if you've, been hacking around on it. Once you restore it to its configuration or you do your repair, you want to get in there with a hard bristle brush and give it a good wipe with your isopropyl or whatever it is you use. So yeah, I would have got in there and measured voltages, visual, have a good tidy up. And yeah, then, well, I don't know if it still wouldn't have worked after that. I don't know what I would have done, because we can't get the schematics for this thing, and it happened on both channels, and, well, it's not actually a real hardware fault. It seems to be just like a software-induced fault. So that's weird. Anyway, that is fascinating. Not entirely pointless video, but yeah, a bit embarrassing, but I always post my embarrassing shit. I don't care. Anyway, hopefully you learned something. So anyway, if you liked it, please give it a big thumbs up, and as always, comment down below. Catch you next time.